Hello, I'm MCToon, the worst rapper in the world. Today we've got a flat Earth debate, and we have a guy from Facebook. His name is, well, I don't want to get your last name wrong, so his name is Michael, and your last name is
Gebhart.
Gebhart. All right, so it's a B. I didn't know for sure. So, how you
That's
doing,
German.
Michael?
I'm hanging in there just fine.
All right, and I think it's kind of interesting. People Michael doesn't just live in a house. He has I think a little more interesting get up going. Can you want to tell us a little bit about where you live? I think it's pretty cool.
I live on a 41-foot sailboat in the Florida Keys in Marathon, the island of Vaca, out in the harbor. That's where I'm sitting right now in the cockpit of my boat.
Huh. And that good you've
I,
got
I'm
good internet, it looks like.
not bad, yeah. Or we got enough Wi-Fi around here to keep us going.
Sure.
So
Somebody already said Hulk Hogan. Um so there's
not
a
really.
there's a live chat, people chatting away. There's 65 people in there right now. Um
Okay.
so sometimes you might see me interact a little bit with them, and sometimes some kind of trolls show up, and there's different people that are moderators. So I might interact with them, and somebody else is asking if you build custom motorcycles with your son. Uh,
I built custom airboats with my son and boats and things like that.
I think, what's the name of that show? You know what I'm talking about?
Orange County choppers.
That's it. OC Choppers. Yeah. Oh, my kid loves that show.
I do ride though, yeah.
That's all cool. And so you probably do you keep it on the boat or part you probably
Oh
not,
no,
right?
no, no. It's other than the fact that I live in a boat rather than a house, life is pretty much normal. I got a regular job in town. The only difference is my family car is a small boat that I take in each morning into the what we call the dinghy dock. Get out of that. I walk over, get in my car. Actually, I get on my bike and I ride to work.
Oh, that's pretty nice.
It's just a little added step. It's just the life down here.
Yeah, that's cool. That's cool.
I'm in a harbor with literally hundreds of liveaboards out here,
Oh, so a
cruisers.
lot of people do it.
Oh yeah, this
Okay.
place. This is the largest mooring field in the country. Over 450 boats. Sometimes people come in from all over Chesapeake, Annapolis. They come down here for the winter. They put their boats out here on the ball. I'm one of the ones. There's a few hundred of us that are year-round liveaboards here.
Hmm. Well, that's cool.
Nothing you can have in a house that you can't have on a boat, except maybe a lawn.
Yeah. Yeah, I just mowed the lawn here first time this year, so
Well, I did that once about 15 years ago.
no more
Been a
house.
little
Yeah.
while.
My
Yeah, back
my
in the house
dad's in
days.
Arizona. There's just um rocks. Don't no lawn there, so
Yeah,
oh, somebody said they had snow today. Wolfgang, where are you that you have snow? That's
I heard something about snow in New England.
oh. Yeah, it was cold last night. They said frost warning. So, oh, Finland. Yeah, it's always snowy in Finland, right?
It was a little chilly here. It was only about 75.
Oh, nice. Yeah, it gets to it. I don't think it got to 65 today. So all right.
Six,
Well,
75. All right.
let's get to the topic here. We've got a little bit of a flat Earth thing going. You were on. I think Flat Earth United was the Facebook group. Is that right?
I'm on several of them.
Yeah,
Yeah, I'm on several of them. So,
I'm in a bunch too. I enjoy the talk. So
well, there's a lot of debate on it.
there is, yeah. Now I did not present or prepare anything in particular. Sometimes I do, but there was a last minute change. There was the guy I was gonna debate was about 5G, but he
Hmm.
had a pressing family issue he told me about yesterday. I said, you take care of that. So
Well, I'm fairly up to on 5G as well. Maybe we can touch on that if you like.
yeah, if we get to it, that'd be good.
Hmm.
So what is it that makes you think the Earth is flat?
Well, I can tell you the story, how it all happened. It's just having one of those YouTube binge watching nights, and I came across an interesting video. Just a engineer said, "Save me from becoming a flat earther." I watched the video, and he was an aviation engineer, uh, aeronautical engineer, and he was bringing up. I mean, I'd never heard of it. This was about 7 years ago, and I thought, "Oh, this is going to be a hoot." So I watched it, and I listened to some of the points he was making. And I've got 10 years as an aviation electrician, instrument technician. And a lot of the stuff he was talking about was referencing gyroscopes, inertial navigation systems. And I was listening to the way he was applying it. And I started saying, wait a second, this guy's right. What he's saying is accurate. And that kind of lit the fuse. And I started digging and been researching on it ever since. And I've gone out and taken quite a number of the some of the information and gone out and done my own verification and experiments myself out in the real world, which is quite easy to do here in the islands. And based on a number of factors, it became quite clear that there was not really any debate on it in my mind. And one of the principal supporting aspects of that is that I routinely ask people if they say I'm crazy. Fine. I say, okay, well, provide me with your proof that you live on a ball. Why do you believe you live on a ball? And I ask only that it be something real, something I can verify. I can provide those for flatness. So if anybody can come, and nobody over all my years of doing this, nobody has ever been able to provide that answer. Something real and verifiable.
Okay.
And want to say a picture from NASA? I have no way to verify any pictures from NASA. Moon landings, how are you going to verify that? Mars rover, how are you going to verify that?
Sure. Okay.
So if you can give me something I can verify, hey, I'll sign off. You win. Bingo. No problem. Just that simple.
Okay. Well, I think I got one that's pretty simple here.
Okay.
Let me I got to pull it up here, but I went this summer. I was on a trip to Alaska, and I flew back. It was a overnight flight. So let's see here. And I had installed on my phone the app called the Theodolite. So the Theodolite app I was running.
I'm not familiar with it.
So you know what a Theodolite is?
Not off the top of my head,
Okay. A theodolite is a precision angle measuring device used by surveyors. So it measures both vertical angles and horizontal angles. So they call it zenith and azimuth. But we don't we don't ourselves use those technical terms. So, but yeah, I'm sure you know some of that. So you might call it like heading or bearing for so I have, let me there it is. All right, so let's see, that's not working. So you see, you're seeing it, but I don't have the right thing showing for the people at home. They just see.
Well, I'm not really sure what I'm seeing here. It just looks like perhaps a view out of airplane window.
It is, yes. So all right, let me try to fix this so the people at home can see too, because they see a second copy of it, unfortunately.
All right.
So that's not right. Window capture. There it is. Browser. So, all right. So the Theodolite app uses the internal orientation hardware inside the phone.
Okay.
All right, there we go. People can see it. All right, so it is it's accurate to 0.11 degrees. 0.1 degrees. The phone, the iPhone 7 Plus that I was using, is accurate to I know what I'm doing wrong. Is accurate to 0.011. That's where the 11 came from. So I'm having a little struggle with it. All right, so that's the accuracy to it. So when you can tip it up and down, and you can see across the middle there is a horizontal line that's kind of thick, and so what that is that's eye level.
Mm-hmm.
So the app has you can see on the right hand side 0.1. All right, so it's tipped just slightly up. That bar just there's actually two lines going across it. So the top line, they're right next to each other. The top line is the slightly up, and the second line is 0. It always keeps the 0 on the screen. So you can see that circle there. That's the moon.
Okay.
So the moon is completely below eye level.
And your point is what?
And then down below that farther, you can see the clouds actually. So if we're on a sphere, then the horizon must drop as you go up in elevation, and this is at 35,000 feet. So the horizon has dropped. In fact, it's the moon is below eye level. So if the moon is actually
the moon's position is relative to the time of day.
It certainly,
depending on the time of day.
It certainly is, but if the moon is lower than 35,000 feet, then you would expect to see it below that line.
Who said the moon was lower than 35,000 feet?
Nobody. I'm just saying if. But if the moon is higher than 35,000 feet, then it must be above that line because of the law of perspective.
Well, that depends on time and your location relative to, on Earth. That's all relative information.
But now you don't think the moon is below 35,000 feet, right?
And certainly not.
Okay, so if the moon is always above 35,000 feet, then regardless of the time of day, it could never appear below eye level when you're at 35,000 feet due to the law of perspective.
No, the moon, the law of perspective doesn't apply to the moon, a moving object in the sky. The law of perspective applies to the horizon relative to the observer.
The law
moving object. Well, you could apply the same thing to an aircraft flying out there.
Yeah, you can use the law of perspective to determine anything, any physical object, the position of anything.
Okay, I'm going to make a quick couple points here.
Okay.
First, that I have done sufficient tests and experiments and research to determine the flatness. I'm satisfied with the Earth being flat. However, now see what you're doing right now is presenting me with a scenario that I can't directly, speak on because I'm not familiar with it. But the point is that the fact that I've determined that the Earth is flat does not automatically, bestow upon me the answers to all questions. All right. All I can tell you is whatever you observe on a flat Earth. It happens perfectly normally. The only thing that changes if the Earth is flat is the explanation of things. Nothing else changes, just the explanation. So you present me with, you ask me to talk about and debate this, right? Well, I can debate it in certain aspects. I cannot talk to an astrophysicist about certain formulas or applications that he is aware of that I'm not familiar with. So I understand what your point is, but from my perspective right now, I don't know if that plane is banking, which your relative angle would change and you wouldn't notice it.
Well,
I don't know what time.
For reference, a Theodolite app would not be affected by banking because it's.
Well, that would depend on what its reference is. Is it using accelerometers? Is it using directional information? Is it using just like gravitational pull? What is it referencing its orientation to?
Yeah, it uses accelerometers.
Okay, accelerometers can be you can turn and bank and not change your relative acceleration.
Sure.
You can rotate that plane around its own.
Yeah. So you asked for something
axis.
You could verify yourself. So you could download the Theodolite app yourself and take a flight.
Well, this is a. Well, no, I mean this. I'm not going to say it doesn't, but I can't speak authoritatively on this particular app. That's even this is somewhat vague. You'd have to go and research position of the moon. I mean, there's no way to verify, the relative orientation of the aircraft. There's a number of factors here that are just there's too many variables here to call this definitive evidence.
Yeah, and
At best, it's circumstantial.
So that's why I'm suggesting you do it yourself, right? So if
Right.
the plane is banking,
things,
then you could be on a plane and you could use, you could do your observation when the plane is not banking. You do it a whole bunch of times. You can do it when the plane is banking, see if that affects it. You could do it when the plane is not banking.
What you're trying to do here, you're trying to provide proof that it's a ball or sphere. Well, there's easier ways to go about determining that. I mean, we have, just mathematics, geometry. Given that the Earth is 24,900 miles in circumference, we can calculate the amount of curvature per mile. It's said to be 8 inches a mile. The formula is 8 inches times miles squared gives you relative number of inches of curvature.
Can you derive that formula?
Excuse me?
Can you derive that formula?
You mean like as in it's where it comes from?
Yeah. Can you yourself derive that formula starting with with first principles?
Well, I don't have it with me, but it's actually 7.98 inches of curvature per mile. But anyone can go and Google like Earth curvature calculator.
Yeah, but that's the wrong formula. That's my point of asking you to calculate it.
Wait. I've heard this many times. You say it's the wrong formula. Okay. Well, that is questionable because most people say that it's the wrong formula because it results in a parabola. Correct?
That's not why it's the wrong formula.
Why is it wrong? Okay, what's the right formula?
It's the wrong formula because it doesn't take the viewer height into account.
Absolutely, it does.
And so where do you plug in the viewer height in that formula?
No, this is a zero perspective formula. The basic formula does not include viewer height.
Okay, and so how do you account for the viewer height then?
If you use the Google Earth curvature calculator, that's one of the two parameters plugged into it: viewer height and distance from object.
Okay, and but no actual calculator that I've seen online uses that formula. It uses the correct formula.
Okay, and well, regardless of the formula that it uses, when I use it down here, it's like I said, I live in the islands. We have lovely little things called the 7 Mile Bridge right next to me. We have offshore lighthouses. Okay. And we have one that's about 3.5 miles offshore. We are on a thin ribbon highway. Now I can see that lighthouse in excess of 20 miles away. That lighthouse is 142 feet tall. Now you just plug those basic numbers in.
What's your observer height?
At the standing on the shoreline, so call it 6 feet.
Okay. And the lighthouse is how tall?
142 feet. It's called Sombrero Lighthouse.
Okay. And yeah, there's no problem seeing that.
Really?
Do you see the calculator that's on the screen right now?
I can see it, yep.
Yeah. So I put in your...
No, it's not. No, you got distance between observer and target. I said that the lighthouse is 3.5 miles offshore, directly south of the islands.
Okay.
My observation point, see, everything down here in the Keys is done by mile marker. Key West is a 0 mile marker, and you get up to Key Largo, it's a 106 mile marker. I'm at roughly the 49 mile marker here. Well, I go down the Keys beyond to a place south of Big Pine, which is just about 21 miles south of here. So it's I'm about 21 miles west of the lighthouse, and the lighthouse is about 3.5 miles south of my position. All right. Now, at that distance, it is actually quite small. It's hazy, but it's clearly there. Now, at the lower portions of the lighthouse is the old light keepers. This is basically a wrought iron station, but about 20 feet off the water, it has a large platform, basically a big room where all the equipment is at. At over 20 miles away, you can see that room not 20 feet off the water. And I see this every day. Now, I'm perfectly happy to have you put in your numbers into your calculator and tell me how much of that I should or should not be able to see.
All right.
I'm fine with that.
So what's the distance?
About 21 miles. That's the last point. I actually have a clear view of it without trees in it.
And there's land in the way, or how are you seeing it?
Well, there's just well, you can't get to every place because it's parks, it's homes. You have to get to some place where you can be on the shore that you're allowed to be there. So it's not always a clear view. You have to find a piece of land where you do have a clear view.
Okay.
So if you're by the road or whatever, it's just I can't walk in people's backyards. So there's only certain places I can go.
Sure. So I'm just trying to get to have the right measurements, right? I don't want to use the wrong.
That's fine. Okay. Yeah, granted, at 3.5 miles, it would be no problem, obviously.
So do you have like pictures of this or anything, or?
I do. I don't know. Can I actually access them right now?
Yeah.
Well, I don't know if I. I mean, yeah, I could. I mean, it'd take me a minute to find it.
Yeah.
But I've actually taken.
And of course the position would help a lot.
The position. What do you mean?
Like an accurate position instead of just kind of a guess.
Right? You mean position of what?
Where you were when you take the picture.
Oh, I know where I was. I was on Big Pine Key, which gets down to about the 32. So that's about roughly 20 miles there. It depends. I mean, I've done it several times, but just based on the numbers I've handed you already, I mean, see, I don't just see I don't see the top of a lighthouse. I see all the lighthouse. I can see the boats. I mean, this is a big dive site down here. I can see the boats in the water. Now, granted, they're just little dots at that range, but I can see them quite clearly.
Mm-hmm.
We're talking boats that don't sit more than a few feet off the water. Speed boats, 16, 20-foot speed boats. I mean, granted, there's a lot of dive boats as well, but that's just one example, that, I've specifically gone in there and, there you go. Okay, Boot Key right there in the middle of your screen is right where I live.
Okay.
That small harbor just up above it. Now, if you go directly south of there, well,
In Boot Key.
3.5. Yep. Straight south. I don't know if you'll have it on there.
Like in the water here?
Yes. 3.5 miles offshore. There's Sombrero Light straight down from Marathon, due south.
Okay.
You're jumping around a lot there.
That's down to now Cuba.
Yeah, we're a little. Yeah, just find where it says Marathon or Boot Key.
Yep. There's.
Yeah, just zoom in.
Yep. There's Boot Key.
Yep. No. Straight south of there. You'll go out and you'll see the reef. You just keep scrolling down. I think you got to go a little further. Whoa, right there. Now, if you zoom in there, it looks like the reef line there. I can't tell. It's not a lot of definition there.
Yeah. Oh, there it is. Sombrero Lighthouse.
Yeah. Sombrero Lighthouse. Mm-hmm.
All right, and then like you're viewing it from somewhere on Boot Key here.
Head west. No. Head west.
Okay.
Keep going.
You got there's Honda Key.
Bay Honda, and right there, you see where that road makes a sharp turn there?
Yeah.
Right there. That point right there. There's a little beach right down in there.
Big Key Fishing Lodge.
Spanish Harbor Channel. Yeah, right in there. A little marina right there.
So like right off this point here?
Yeah, well, I can't really see where that point is, but it's a little closer to the road where I was at. Yeah, relative right in there.
All right, so that's 13.92 miles.
Okay, that's triangulated, so yeah, that would be.
That's just a straight line distance using Google Maps. So, all right, so we'll go back to here, put in 13.92 miles.
Mm-hmm.
Everything can be observed at the top of the lighthouse, and the hidden part is somewhere around 65 feet, maybe, that are supposed to be hidden.
Okay. All right. Now give me a second here, and let me see if I can find you a picture. I know I've got it. You still there?
Yep.
Okay. Just want to make sure. And take me a second here.
Okay.
Okay. Oh, look at that. I found it right away. I have no
Sombrero
idea.
Key.
Well, sombrero's not really a key. It's just a reef. Okay, I got the picture. How do I get it onto you?
There should be a share button on the screen
Right.
somewhere.
Got it. And then share it to what?
In Zoom, you should have the option to share. Oh, I'll stop sharing mine so that you should be able to put yours up now.
Looking here. No, I'm not seeing a Zoom in here.
No, Zoom is the app you were using. So if you go back to Zoom,
Okay.
so I've not used the actual mobile app myself, so I don't know exactly how to share within Zoom. But there's a way. I've had people do it before.
Okay, I gotta find it right now. How to get back to you right now?
Yeah, so if you go back to Zoom, and it should be on the screen there somewhere.
Okay, there it is. Okay, yeah, there's a share. All right. Well, this particular one was taken at 19 miles.
It was taken at a different spot.
Yeah. Well, there's different spots. I said error. Try it again. I'll go gallery. It says unsupported document type. Please select an image or PDF document.
Oh, is it an image?
Yeah, it's a photograph I took on this phone.
Oh, that shouldn't be a problem.
Well, that's just what it says. Actually, I've still got you on Messenger.
Yeah, you can send it that way.
All right, let me just pull that up and give me a second here, and I'll put it in there like that. Okay, gotta find it. So,
Yep. I don't know. I always prefer a desktop computer, but I've been writing software for years, so.
yeah, I'm sure you do that. Okay. All right, I got it off to you. Now, bear in mind, this is taken with just with my phone, so you're gonna have to zoom that up. And I don't have full zoom capability, but
Sure.
anything great.
Right.
Now I just got to figure out how to get back to. Okay, there it is, right there. That should be. You get it?
Yep, I got it, and I'm putting it up right now. There we go. So
The
let's
text
see.
I did myself.
Yep. So we see kind of a darker spot there, yeah. So we see something, and it certainly could be the lighthouse, which does not have any. Well, if we could find where you took it, maybe better because
Well, like I said, I know that the lighthouse is directly south of the 52-mile marker, and we have mile markers all along the road, and I put 19 miles on it, so
so
that'd be like the 31 or something like that.
so where was it on Ramrod Key? Because that's 19
No, it's,
miles. Now,
I,
how did you
I,
get 19 miles?
I was just going by the mile markers on the side of the road.
Okay, so you
I mean, I
just
appreciate
rough.
that the lighthouse is like I said, 3.5 miles offshore, but the linear distance was relatively close based on just the mile markers.
Okay, so was it on Long Beach Drive here on southeast? Let's see, southeast point of this
Well,
coupon
I
bite.
can't really say for sure, but the point is that at that distance, I shouldn't be able to see it at all.
Well, it
I mean,
depends.
that's just based on.
Yeah, if 19 miles maybe, but I don't think that you've very clearly determined it was 19 miles.
Well, at the time I did. I mean, that picture is a few months old, so you just asked me if I had one. That's all. I
Sure.
mean,
So,
I'm
but
relatively unprepared here. I just thought
yeah,
I'd throw
I get that.
myself to the wolves and see what happens.
Yeah. So the problem is when I put in 19 miles from that see, I'm kind of swiping across here to try to find 19 miles.
Well, I'm going by. You can't go by dead linear mileage because obviously the road turns around and the mileage may be relatively different within a few miles. I can't really say exactly the distance. I didn't measure the actual line of sight distance.
Okay, so it's a rough number. So I
It
mean,
is.
that kind of science is a little sloppy, right? So
Well, this
it's
this
hard to draw a strong conclusion from it's about this distance,
okay.
you know.
Well, that's not an isolated incident. I mean, you can look. I mean, I've stood on the shores of Lake Michigan. I can see Chicago 62 miles
Yeah, I've seen those too, and the
lake.
bottom is cut off. So
No,
um,
well, yes, but here's the thing: the bottom has to be cut off. I can hold my thumb up at arm's length and block out an entire city. A few miles away,
yeah, but if nothing's in the
right?
way, then nothing would be
But there
blocked.
are there are waves down there. A wave 1 mile away that's 4 feet high could easily wipe out, something that's 50 foot tall 20 miles away. So yes, the bottom
Only if
will.
you're below four
No,
miles.
wait. Huh?
Only if you're
No, wait a
below
second.
4 miles.
The
Or sorry, four
curvature at
feet.
that. No, that's not the case. I mean, I could hold my hand up right in front of me and block and put it along the shoreline and cover up the entire city. So
Sure,
anything
but you need to get that
as
wave
with
between
perspective,
you.
with okay,
Yeah.
yes, but as perspective goes, the sky and the sun and the water come together, and everything gets smaller and tighter as it with distance. So a wave 10 miles out is going to be very, very close to covering up half a city that might be 60 miles away. Point is, at 60 miles,
Only if that
wait, wait,
wave is really
well,
really
see, you're
tall.
talking about the bottom. You're talking about the bottom. At 60 miles, I shouldn't be able to see the top unless the buildings are over half a mile tall.
Well,
I've stood on the shores of Lake Michigan.
we can run the numbers again. So your first example didn't work out too well, but we can do more Lake
Actually,
Michigan
it
if you
works out
want.
just fine. It works out just fine.
But you didn't substantiate your 19 miles. You first you
That now you're splitting hairs there. You're getting into real specifics.
the difference
You
between
know,
13 and 19 miles is a big difference when you're talking about whether or not
yes, it
something should
is.
be
Yes,
seen.
it is.
So that's not splitting hairs. I'm
No,
not
I
gonna.
can,
So
but I
your very
no.
first one, you said
So,
this was the spot right here, this southeast point on this
well, I
key.
can't see it on screen right now.
Okay, yeah, on Big
I
Pine
see you.
Key,
That's about it.
right?
Hmm.
So on Big Pine Key, you took that picture of the lighthouse,
Yes,
which is
I
13.9
believe
miles
that.
away.
Hmm.
not 19 miles away. That's not splitting hairs. That's a big difference. That's 20%
Well, I said
difference.
that particular point that you pulled up on your Google Maps was one location where I have seen it. I am there routinely every day. Now, different, sometimes you can see it, sometimes you can't due to atmospheric conditions. But there are plenty of other places along the way where you can see it. That just happens to be the one. When I took that particular picture, I was judging by the mile markers. I was 19 miles away. That's how I knew that.
Okay, so
I didn't.
scientists don't just be like, oh, look, the mile markers is about that, so we're not going to split hairs here.
Yes,
we're just going to use some whatever numbers we want.
But see, you're getting real specific.
Absolutely, I absolutely am going to get real specific because you're claiming the Earth is flat. That's a very specific thing that can be tested with very specific science.
And it has been by lots of people. I mean, you can break this down to smaller numbers. I mean, there are plenty of experiments out there that have been done. You're familiar with the Bedford level experiment, I assume?
I absolutely am, and I'm aware of how it was done later properly, and Robotham wouldn't even look in the telescope.
Well, since you mentioned telescopes, that's another interesting point. With a telescope, I can see much, much further. I can see, lighthouses work. Their light can be easily seen out to sometimes over 100 miles.
Okay, so let's go with some examples then, rather than just, stuff, right? So if you've seen things, then certainly, you want to do stuff yourself. You said you've done stuff yourself, right? So,
mm-hmm.
Do you have any more that you did yourself that you want to look at?
Well, there's a plethora of information. If you want to bear in mind that I didn't come here specifically prepared. You said this was going to be a debate,
yeah,
not just a nitpick my experiments. The point is that I've plugged these numbers in to both the basic formula and Google Earth curvature calculator, and
I'm not aware of Google Earth curve calculator.
Just pull it up online.
No, Google doesn't have one.
Okay, well, it's Earth curvature calculator. Just Google that. I won't say it's necessarily Google's.
Okay, I got confused because you put Google in front of it. So the first one that comes Google up is from GitHub. So if you're not gonna, a lot of them don't take refraction into account, and if they don't, then it's not very accurate. So
refraction.
Yeah, you can't ignore conflating variables when you're doing science.
Okay.
So
you're gonna tell me that by refraction, every time we see it, we're looking around the curvature of the Earth.
Absolutely, yeah, it's been confirmed that light curves.
Light curves everywhere. You're saying?
Absolutely. You're wearing glasses, and so am I.
These are my readers.
Yep. Mine too. I don't wear them except when I'm reading. So, and Snell's law is well understood. The index of refraction is well understood, and people have quantified what they call the coefficient of refraction, which is the radius of the curve of light as it passes through a gradient medium like the air. And they actually use
it only curves following the curvature of the Earth. It doesn't curve in any other direction.
It in extreme circumstances, it sometimes can curve curve up instead of down for short times. But when that happens,
circumstances, what would those extreme circumstances be?
It'd be some pretty strong weather conditions. Typically, you'll have
on a crystal clear day. How much refraction you can have?
Well, the temperature change is also the big deal. So when you have water that's warm,
pretty much 85 degrees here all the time.
Yeah, when there's water that's warm and air that's not warm, different things happen, and that's where you get these more extreme changes. But there's typically some other visual indicators when there's basically the air is inverted from what it normally is. So you get all sorts of wavy things. You get different things that are highly distorted.
Lake Michigan's extremely cold, and it can, obviously the weather out there is cold as well.
Yeah,
down here, the water's warm.
Yep.
And you see the same effect.
Yeah, it's not the temperature alone; it's the temperature gradient. So when people are being very accurate about things, they capture what they call the lapse rate. That's the temperature at different elevations as they go up, and so you use that to calculate the coefficient of refraction. Very rarely is that captured. There is one group of flat earthers that did capture that. FE Core did that, and they measured it. And unfortunately, it didn't work out well for them because the lapse rate and coefficient of refraction in their test, their laser test against across Lake Balaton, showed definitively that there is a strong coefficient of refraction going across there. So it didn't work out well for them there.
Okay, well, what are you quoting the curvature of the Earth per mile at?
It's that's the incorrect formula. It's
I
not
didn't say a formula. I asked you what the actual measurement was per mile.
the actual measurement per mile.
Call it 1 mile. How much curvature?
In 1 mile, yeah, just a little bit under 8 inches.
7.98.
Yeah.
And at 2 miles, 3 miles?
Then it's yeah. But
How about 3 miles? Let's pick 3 miles.
yeah, go ahead.
No, I'm asking you a question. What you would quote that curvature at?
I don't know.
24 inches?
I would instead put it into the formula because that's better. But the key is if you're going to be doing that with based on observation, again, you have to take the observer height into account. So I would never use that
Absolutely.
formula if it's about something you're seeing. Because seeing things, unless you're on the ground, eyeball half submerged in water, then that formula does not in any way take the height of the observer into account.
Okay. All right. We're not getting anywhere that way. Let's try a different one. Let's say you're standing on a beach, 6-foot tall guy standing on the beach, looking out to sea. What range do you put the typical horizon at?
It's usually about 3 miles out.
2.9 to 3 miles, correct.
Sure.
And why can't we see past that point?
Because the curve of the Earth is obstructing.
Okay. Now, if you look out to sea, and I have a very good perspective for this down here, my horizon's at 2.9 miles. That means between me and over that 3-mile distance, the Earth is curving, correct?
Yes.
Yet I can look horizontally along the horizon, and there is no curvature. And I can see, well, I don't know, what's 180 degrees of horizon equate to?
I don't know.
Well, if it
you must
curves
have
so much in 3 miles, it obscures things beyond that point. I'm looking at probably easily in excess of 50, 60 miles.
Sure, yeah.
Yet
So
it's a dead straight line.
so if it's, let's say it was 69 miles,
Okay.
right? That would be 1 degree of curve. Can you see with your eyes 1 degree of curve?
Well, you're saying that 1 degree, this 3 miles of curvature is sufficient to obscure things behind it.
Yeah.
Yet
yeah.
I can look at 69 miles of curvature or horizon and see no curvature.
Yeah, the left to right. Yeah, left to right is much harder to see.
And actually, there's many places down here where I can see close to over 300 degrees.
Yeah, but your eyes aren't that wide. Like we're not birds, So
No, I can't see it all at the same time, but I can scan around. I live in the islands out here. I have horizon completely surrounding me. Or say you're out on a boat. The entire horizon around you. That would be say you're just standing in a rowboat in the middle of the ocean.
Okay, so
your horizon's going to be 2.9 miles and 360 degrees.
Sure, but as soon as you turn, you lose your point of reference from the previous position. So you can only see what you can see with one view. So can you see 1 degree of curve?
I don't know.
Do you think you
can see a curve? I can see curvature.
So
if it was curved.
Now A good thing to do would be to maybe get a straight edge and put it up against the horizon.
We did that. We did use it. I got an 8-foot level we put out there.
And then did you take a good picture of it?
No, I don't have that. Most of my stuff is not preparatory for getting into debates. It's for determining things, just based on observation, logic, formulas, calculations like that. I don't bring it out as a rule to try and prove it to other people.
Okay. Well, a friend of mine, Rory, did that. He went up to, he used his iPhone 4. So it was a couple years ago, but he likes his old phones. So let me send you
old phones. I'm using an Android. I'm not an Apple guy.
Yeah, that's fine. So all right, so there you go. You should see it now.
Oh, I can see that. Yeah.
Yeah. So let me see if I got. There we go. All right. So this is it's a bit of an explanation that I went through here, but he went up to a spot here. This is he put together a couple levels. It's pretty wide. This is in Ibiza, which is in the Mediterranean Sea.
Mm-hmm.
And that's the setup. That's not the actual test. The test is this one here. So he has lined up the horizon between these two straight. I'll zoom way in here. You can see here the horizon is right between them, right? So you can pan left to right here, and we can see it changing in orientation. Now, it's hard to see, just like when you're standing yourself on the shore. It's hard to see because our eyes are not precision measuring devices, right?
Mm-hmm.
When we're at the hardware store, if we're going to buy a piece of wood, we don't look at it wide to see if it's curved. You look down the end because we're not good at that.
Certainly.
So when you look down the end, what you're doing is you're compressing it horizontally. So if we take that image there, and you can go to the website here, MCToon.net is my website. This is on there. You can do it yourself. Anybody watching can do it themselves. Grab this image. It's the original image off of his camera. It's actually got all of the EXIF information, including the GPS coordinates that he took it, so somebody could even go to the same position if they wanted. And then take it into Photoshop and do this with it. That's just a horizontal compression, and then you see the curve of the horizon there.
It's interesting. I'm not going to call it conclusive because it would take some time to verify that.
Yep. So and like I said, you can do it yourself. You can look at this image yourself. Now he's not the only one that's done that. Friend of mine, Tommy Gronfeld, which I get his name. I got to get a name wrong every time. He did the same thing.
Somebody that didn't prepare for this too well. You seem to have a good bit of graphics.
Well, this is just on my website. So, like sometimes when I do a debate, a lot of the time I like to have like a unique thing that people haven't seen before. That's all. So, like the people watching, I think a lot of them are probably gonna say, "Yep, I know what he's doing next." So, anyway, this is from Tommy. Tommy lives in Norway. All right, I'm zooming around a little bit there, but all right, so he's got this straight edge here that he set up, and he has same thing. You can download the original 45 megabyte file. That's the raw file off of his camera that has all the EXIF information in it. Mm-hmm. Same thing here. You get the left to right view when you zoom in. So what I did for this one, I went into Photoshop and I counted the pixels. It took a while. People are saying mention the URL. I'll put the URL in here. So the MCToon.net is the website, and this is left to right curve. It's right on the thing there. So anyway, I counted the pixels, the actual pixels. I also have the Photoshop file that I used to count the pixels that people can download. It's a
okay. Well, there is a problem with what you're doing here.
Well, hold on a second. Let me just show you what I did here. Then I brought those numbers. I put them into Excel, and I graphed the curve in Excel. And you can see here it used you can put it into a polynomial. So it did that. So we got negative 0.011x squared plus 1.2 something x plus 7.8. So it is a curve. when you plot out the actual points. So, all right.
Absolutely, it's a curve. You betcha.
All right. So, what do you got?
Well, see, what we're looking at here, that horizon is, like I said, if we put ourselves in a boat in the middle of a perfectly flat ocean, okay, and you look at the horizon, all right, and you turn yourself around 360 degrees, you'll see a straight line there, okay, and but it's not a straight line. It is actually the arc of the limit of your sight. It is basically a circle around you. All right, you follow me?
Yep.
It's like standing in the middle of a dinner plate. Now, from your perspective, in the center of that dinner plate, what you're seeing out there is the arc of the limit of your vision. And yes, that is a curve. All right. Now, if you place a straight edge against that, there is a detectable curve, absolutely, but it is the arc of the limit of your sight, not a curve going towards you and away from you. You know, it's curving away from you. It's actually the limit of your vision.
Okay.
The vanishing point of the horizon, where the clouds and the water come together. You can follow that around as a circle. Can you not?
Yes, you can.
And from the high perspectives you're at, would you not interpret that as a curve?
Certainly.
And that is what you're seeing there, both with your level experiment and with your calculations here.
But I went into this because you claimed the horizon is flat. And now you're claiming the horizon is curved.
No, it's a question of perspective. It is absolutely flat because every point you look at is at exactly the same relative height.
Okay, so
all right, now that is flat.
So is your point that you cannot use that as a analysis of whether or not it's flat?
Essentially, what I'm getting at there is that yes, you do. There is a detectable curve out there. It is not a spherical curve. It is the curve of the arc of the limit of your vision.
Okay, and so how would we differentiate between a spherical curve and a curve on the that's the limit of your vision? How would you tell this one says the Earth is flat, this one says the Earth is a sphere? How would it look if it's a sphere, and how would it look if it's flat? Because let me remind you, I brought this up.
This is not a question I'm prepared for, so I don't just I don't have spontaneous answers.
Would you say you're not prepared for that?
Of course, yes.
Now, would you actually just say, quote, "I'm not prepared for that"?
I'm not prepared to give an answer.
Oh, darn it! I was hoping that. There's a a famous debate where the other guy kept saying, "I'm not prepared for that." So anyway, but this started when you were bringing up that the horizon is flat, but that's not what you were bringing up.
The horizon is flat. Except my point is that now wait a minute, it doesn't stop there. The limit of our vision, all right, where the horizon's at. You say the Earth curves off behind that, and that's at 2.9 miles, correct?
Yep.
And that what we already established?
Yep.
So anything beyond that point, I should not be able to see. Is that your contention?
Not anything behind that. Things that are close to the ground will get obstructed bottom up as they get farther out.
Okay, how about a cruise boat 30 miles out to sea?
Yeah,
I can see.
Yeah, the bottom. The bottom.
Yes, the bottom will be obscured, and I already touched on that because the further out we go, any wave in the water, halfway between us can virtually cover up almost the whole boat. But the point is that
no. All right, let's go back to that. I go out
with a telescope. Which one?
That claim that because this is pretty interesting. A wave, like a 4-foot high wave, could block half.
Numbers
could block half of a boat.
These are not specific numbers.
Okay.
I'm just saying that there are waves out there, and they do obscure a close wave. I mean, we get 4 to 6 foot seas down here all the time. That's nothing.
Okay, so
and they build up as they get further out. I don't know specifically what the height of the waves is at any given moment, but I know that there's significant waves out there all the time. And yes, they will obscure the lower portion of the ship just due to perspective. If I got a ship that's 20 miles out, I got a 5-foot wave 10 miles out, that could, depending on my height, that could easily cover up. It's absolutely going to cover up the bottom portion of the boat.
all right,
It's not
so
due to any curvature because that boat shouldn't even be there, from my perspective.
all right, so we've got a
And if I get a good telescope, I can see twice that far.
All right, so let's run some numbers here, right? Because I can do the calculation. So, if the viewer is 6 feet high, right?
Okay.
And let's put a 6-foot wave, right? I'm drawing a picture here, right?
Well, I'm still on your Excel chart.
Yeah. Okay. Let me pop off of that there. So.
Yeah. Now that screen's getting dull.
There we go. All right. So I got it going right here. Oh, it doesn't show up too well yet. Oh man, maybe I have a.
Well, you follow my point though. How you can hold your hand up.
Oh, I can.
And cover.
But
cover up a skyscraper a mile away with your hand, or just
yeah. But that thumb isn't a the same height as a wave.
The thumb hand wave is irrelevant. I'm just saying that anything, these waves, you got waves all the way from where you're at all the way out to the ship, and say the waves on the ship are going to be the same size as the ship. The ones in front of it, say half the distance, yes, they are going to obscure, the lower half of the ship.
All right, so I've got here, let's see. We've got the viewer at 6 feet, the wave at 6 feet, and the ship at 30 feet, right? So according to perspective, no more than 6 feet of the bottom of the ship could be obstructed by that wave.
That's not an accurate depiction.
Oh, well then, because you do you have an accurate one then? Can you correct me on that?
I can. Well, yes, because the water and the waves are at the level of your feet, the same place where the bottom of the boat is at the level of your feet. Your eye looks, down, and you basically form a triangle. Your body is one side of the triangle. Your eye, the angle of your eye to the ship is another angle, and from your feet at the water line is the third angle, forming a triangle. How would I do that? There's the person standing. Can you see my hands there?
Yep.
There's the person standing. The water is down here at your feet. Your eyes are viewing down this way. And the further things get away from you, halfway in between, the more effect they have on that which is at the horizon because of perspective and the vanishing point. As things get further away, they get smaller. So that ship is much, much smaller at 30 miles than that wave is. The wave presents a much larger target than the ship does at 30 miles.
Its angular size is, but what it blocks, we can just draw straight lines on a graph like this to see what it would block.
Yes,
so
and
that's how you can do. It's an orthographic diagram. You can just draw straight lines on it, and then what you do is you can measure angles actually from it, rather than calculating angles. So I'll show you here. My kid took my ruler. So we've got our, oh my goodness, my green screen. So we've got the angle of it there going up, right? And so we can actually measure that angle there between your eye line and straight out.
That angle would be going down. You're talking about taking the bottom of the boat.
Yeah, absolutely. And so I'll draw that as well.
The eye level of the viewer to the bottom of the boat, you got a line from your feet to the bottom of the boat, from your eye to the bottom of the boat.
Your feet. Line. You don't have eyeballs in your feet, so we don't need to draw that.
No, that's the reference line of the bottom of the boat.
Yep. So all right,
feet in the boat would be at the same.
I added in the view to the bottom of the boat. You can see there
the bottom two lines. The bottom two lines.
Yep. So you can see that wave, actually the bottom half of the wave is not obstructing anything because
I
it's
didn't
not
say
in
the
the
bottom
way,
of I
right?
didn't say the bottom of the wave was doing anything.
Yep. So it's just the top, the top part of it that's going to obstruct. And a 6 foot viewer with a 6 foot wave cannot have any more than 6 feet of the
But a
bottom of the boat
30-foot boat,
obstructed.
yes, but your depiction is completely out of scale. A 30-foot boat at 30 miles is going to be a dot on the horizon.
Sure.
I see them all the time. So it's not going to be a real tall thing like you're showing there. It's actually going to be more closely. You're talking about the vanishing point. The ship out at the vanishing point is not going to be presented very high. It's going to be this. It's going to look tiny on the horizon. I can easily cover up the entire ship with my thumb.
Yeah, and
It's
but your
tiny.
thumb, but the wave is not your thumb, and the wave is lower than that. So,
Yes,
and
and
so we
it's
can,
much further out.
yeah, but much further out doesn't change the trigonometry of it, right? That 6 foot wave, there's no way for that 6 foot wave in this example to obstruct anything more
Well,
than,
if you consider that the finishing point of your triangle, where the bottom of that ship is supposed to be at, the ship is not much taller than the height of that line.
well, if it's a 30
This is
foot boat, it has 24 feet above it that you're still going to see.
very true, meaning the wave obscured the lower half, not the curvature of the Earth.
No, the wave only obstructed the bottom 6 feet.
The part you said was disappearing over the curvature.
Yeah,
I'm saying the wave
that's
is
the
doing it.
most. If the wave is doing it now, a 6 foot wave is not
No, no,
not all
no.
that common, right? But
All we're debating here is that you said the bottom half disappears first, and I'm explaining to you why the bottom half, because there is obstruction out there.
yeah, but in your example here, we need to have a lot taller wave than 6 feet.
Not necessarily, because
Absolutely.
that
That
same ship, I can sit there on the beach and look at that same ship 60, 70, 100 miles out to sea. The Navy does it all the time. I spent 10 years in the Navy. We got radar that goes out 250 miles and more.
uh,
Radar is line of sight. Explain to me how a submarine can pop a periscope up 6 feet out of the water and target a ship 10 miles away.
well, if you want to change topics on this, then and
No,
we can leave
It's
this
the
one.
same. It's the
Yeah,
same thing. It's relative line of
yeah.
sight
Well, you're not going to
dealing with
bring up any
vantage.
pictures from a periscope, are you?
I could. I had some.
You don't anymore though.
I don't know. I actually
Okay.
Googled it and I was looking it up.
All right. So let's unless you have something to present, then it's only hypothetical, right? So
Well, no, it's not hypothetical. Submarines have been targeting ships since we've had submarines. Their periscopes are not particularly high, and they are out in high seas, and they're routinely targeting ships 10, 15 miles out. From just touching on what the example I just gave you, that shouldn't be possible, given that for a 6 foot tall guy, the curvature of the Earth is 3 miles away. You throw a little bit of waves in there, there's no way they would see a ship at
yeah.
10 miles away.
Well, the problem is that
Am I wrong?
you're yeah, you're struggling with the trigonometry a little bit. Um,
No, I'm struggling with, I'm dealing with real world stuff. Not,
you tr-
I use math to do calculations as to what I should be able to see based on the curvature formulas that I've been able to access.
yeah, so if you use the wrong curvature formula, you've probably used the 8 inches per mile squared graph that everybody likes to put up. It's
Well,
wrong.
it's
It
eight
doesn't take
inches.
into account. It never takes into account the viewer height. It only works if your toes are in the
That's
water,
not
or
true.
sorry, your
That's not
eyeballs in the
true.
water.
And absolutely, we use. I mean, it's foolish. And viewer height changes it somewhat, not dramatically.
Actually, it's dramatic. Have you done that, or are you just saying that? Because I've done the test.
Absolutely, I have.
I've done the
No,
math.
I've done
No,
the
no, no.
comparison.
You did not
There.
even know the proper formula before today, so you did not test the proper
What
formula
are you talking
against
about? I
eight
didn't know.
inches per mile
No,
squared.
I don't. I haven't written down. No, I'm talking about calculating in viewer height. All right, and actually, Google Earth. That's the Earth curvature calculator. If you pulled it up, that's one of the two parameters they use: viewer height over distance, and it tells you how much of whatever is at that distance is obscured. Now, I don't need to do that every time to do rough calculations to find out how much the Earth should curve over X amount of miles. And I'm well aware that viewer height is going to change that. All right, that's not that's not what I'm looking for. I'm looking not looking for absolute specifics. I'm looking for general results. And if my general results are showing me that there's no curvature, then
I'm gonna always, as a scientist, always gonna reject just general throwing crap out there, kind of rough estimates. I'm gonna always insist on.
I'm
really
an engineer. I'm not a
things.
scientist.
So, well, an engineer versus a scientist, same thing. Engineers and scientists are about precision, not about sloppy stuff, right?
Well, you told me originally that when I came in here that you weren't terribly prepared for this. You only contacted me about 4 hours ago, even inviting me into this. I'm not, I have a wealth of information or research that I've done, but I'm sitting here talking.
Sure.
I don't have my references right next to me.
Yeah, I get that. I get that. That's fine. But
you've got graphics here. You're pulling up, trigonometric stuff and trying to, and then you're telling me that it's that I don't have absolute specifics. Well, of course not. These are basic observations combined with math and an awful lot of people testing. Right? I didn't make this stuff up. I don't serve any particular purpose by pursuing this path. I believe this path is correct. There are reasons why these paths are correct. And I can pull up dozens of examples that punch holes. Look at flight paths of aircraft. All right.
Sure.
Flight paths of aircraft make no sense.
So like what, for example?
Abu Dhabi to Fort Worth. You look at it on a flat Earth map compared to a ball, on the globe.
Abu Dhabi to where?
The one example I had was Abu Dhabi to Fort Worth, Texas, I believe it was.
All right.
It shows a great circle route where the plane basically flies straight north, almost over the North Pole, and then down through, Greenland, Asia, or Greenland, Europe, and like that, comes down and settles down in Abu Dhabi. You look at that same flight path on a flat Earth map, and it's a straight line. And there are limitless flight paths that can be mapped out exactly the same way.
Well, let's do this one right now. I'll pull up.
I'm not making this stuff up. And
yeah, I do have a little experience with flight paths. Some people in the chat. Some people in the chat are saying, you got to bring that one up. You got to bring that one up. So, all right, Abu Dhabi to Florida.
I believe it was Fort Worth, Texas.
Fort Worth, Texas
was the actual.
And Abu Dhabi. Now I saw one that was recently talking about somewhere other than that.
Oh, there was another one. It was a flight from, I believe it was to Japan to Los Angeles. There was a flight from Japan to Los Angeles. A woman on board.
Yeah, you didn't research that one, so I won't embarrass you by going over that one.
Oh, that one was fictitious, you're saying?
That was, that'll be pretty embarrassing for you. I actually did that one on a globe.
Not going to embarrass me. Not going to embarrass me in the slightest.
It was Taipei to LAX. I have it right here. But let's
diverted to Anchorage, I believe.
Yep, and that's the closest airport. But let's see. I'm trying to get on Google Maps, Google Earth here. I don't know how to measure distance on there.
Well, let me see if I can pull up that particular one I was referencing.
Now, most of the time, what people do when they make this claim is they actually draw the route on a Mercator projection instead of on the globe, and then they say it's on the globe. So, somebody's. Oh, there it is. Great circle mapper. Very nice.
I'm on another page right now trying to find the example I was talking about.
Okay. So that looks like a nice one there. And then maybe we'll do a different one here. SYD. I like this one. This is one of my favorites. QF27. This mapper, I've not used this before. This is good, but I need to show. I need to rotate it. It doesn't let me rotate. How do you? Justin Franks, how do I rotate this? This map here. The center entry at the bottom of under map conf. Okay. The center. Oh, there it is. Center RKV. What the crap is that? It's set to Reykjavik. Oh, that's tough. I need to know where to put it.
That would be in Iceland.
I know that, and that's this particular map. You can enter airport or lat long. Okay, lat long. Oh, I'm gonna have to guess.
That would be useful if I could find the actual one I was referencing. Not 100% sure I saved it, but I believe I did.
Hey, I did a good guess there. So, okay. This is looking good so far.
How is that?
Let's see. Oh, I got stuff ready, so. So you finding your stuff there?
Not as yet.
No.
As I said, I wasn't quite. I was just invited here.
Oh yeah, that's okay.
Not prepared in here for this. But I'm not, encountering anything I didn't anticipate coming in. But I'm pretty confident like this, and I fully expect you to come at me with a lot of details that I'm not prepared to debunk right off the top of my head. But that's all right.
Sure. So, hey, we got Round Thinker. How you doing? All right, so I'm presenting. I don't know. Do you see it yet?
I'm on a different page right now.
Okay.
Let me come back here. Okay, there you are.
So I've got the Great Circle Mapper of Abu Dhabi to Dallas-Fort Worth. You see that? So that Great Circle says that it should go over Greenland, a little bit of Iceland there, and not too far from the North Pole. Does that look about right? Oh, I'm sorry, I don't hear you. I think something happened to somebody's audio. Yeah, I think your audio stopped.
Yep, I actually hit a mute button there.
All right, there we go.
What I was going to say is you may be correct in when you mentioned the type of map used, because what we're looking at here is essentially a flat Earth map. It's not, I appreciate that, but it is relatively referenced on the North Pole. And that would give you the same result.
Yeah.
Follow me?
Yep.
So, now if that map if that flight path was placed on one of the other maps, as in like a Mercator map or something like that, yes, it would be quite different. Could be a poor example. That's okay.
Okay.
That was somebody else's creation, and like I said, you would be correct on that. That the application of the appropriate map would make a difference there.
Okay.
Nevertheless,
So now there's another one. This one here. This is from Sydney to Santiago, Chile. It's a flight that happens multiple times a week.
mm-hmm. Using a flat Earth map.
That is the flat Earth map of that flight.
Mm-hmm.
And here is the Great Circle map of that flight.
Well, I don't have the whole picture on there.
I think you see everything that I'm showing. Right? You see Antarctica in the middle, and then you've got South America on the top left and Australia on the bottom right. So that's flight QF-27 and QF-28 depending on the direction. It's a flight that happens I think it's 5 times a week.
Okay. And what about it?
Was
actually no. I was touching on something that I may be mistaken on, and that was the application of the appropriate map. You may well be correct on this one.
Yeah.
I'm not debating that. I'm not trying to win. I'm trying to be right. So if your evidence is good, I'll admit it. I don't have a problem with that.
Okay. Well, good. So this is QF-27, and I'll just send you a little I'll send you this here. I'm gonna put it in you don't need to look at it right now in your DM, but it that's
I have a DM. What's that?
direct message, mail. Yeah, in Facebook. So all right. Okay. So anyway, so I sent you the link to this one here. This is just somebody wrote a little web thing to plot.
Okay, this is an interesting depiction here. I'd like to discuss a little bit, if you don't mind.
Yeah.
I mean, we've covered the flight path thing adequately. I'll give you your points on that one. And you're probably correct that it was the wrong application of a map there, but it was just one I picked out of thin air. So this, you're familiar with the voyages of Captain Cook?
Sure.
1500s, I believe, where he was sent down to find the inland passage to Antarctica.
Yes.
That was the basic premise of his trip. And are you familiar with the logs of the ship? What happened?
Yeah, I can pull them up here. Actually, I'm working on getting that going here. Give me a second. I gotta turn off the share so you don't see that. Here we go. Do you see me again?
Yeah.
All right.
Fine.
All right. So yeah, go ahead.
Well, just the navigational anomalies he encountered during his voyage down there. You know, north of the equator, everything was fine. I mean, they had obviously the best navigators in the world back in them days. You didn't go to sea; you didn't have half a dozen of them. If one of them died, you're lost at sea. That kind of thing.
Yep.
And south of the equator, they routinely encountered significant navigational anomalies. Now, I don't have the data right here with me, but I have seen it where somebody calculated the distances of navigational anomalies, referencing where they were, at each point. And when they were running, when they were off the coast of Antarctica, they were averaging, I believe it was 15 to 25 miles from where they anticipated being their actual location when they charted it. And people have taken the numbers that they had and determined how far off they would be if they were using like a globe map versus a flat Earth map, because your lines of latitude and longitude change as you on a flat Earth. the lines get wider past the equator, they do not come back together and join it together at the South Pole. Follow that?
Yep.
You go back to the map, you can see it. It's like spokes on a bicycle wheel.
Yes.
And
yep.
that actually jibes with the navigational anomalies they encountered. Not to mention the fact that he spent over 3 years, I believe it was, and charted about 60,000 miles when the shoreline of Antarctica is supposed to be about 12,000 miles.
Yeah, and so his voyages, we have his logs. We have transcripts of his logs. So let me bring up. I've got them.
That kind of time.
Yeah, somebody really cared. So
back in the day.
So there you go. You should see that's the map of all of his voyages. So that's 3 years worth of voyages there. So that's 60,000 miles over 3 years.
Yes.
Right. So, what's anomalous about that?
Well, the amount of miles sailed, and I don't know that these, like the blue lines, are particularly referenced in his Antarctic voyages. But and I don't even know the accuracy of this. I haven't looked into that. This is just basic numbers that were put out there. But
yeah, so I've seen that claim before, and what they typically are doing is they're talking about the entire distance of all of his voyages, and this map is showing the distances of all of his voyages being 60,000 miles. Right?
Okay.
Not
and the navigational anomalies.
I don't know what they are, and you've just kind of made some rough things, so I don't know what. We'd need a little more information than that.
I don't have the wealth of data in front of me that you do.
So maybe that's not a topic
I'm
for
at a
today.
significant disadvantage here. I'm at a significant disadvantage.
That's fine.
I appreciate the fact that this is, beat up on the flat earther thing, that he's crazy and all like that. But my points are not without merit. You're going to a great length here and pulling up things that I haven't personally referenced. But there's a lot of things there's a lot more to this than just maps and like that.
Now, I gotta say, the anomalies are something I've not heard of before.
We should look into it.
And so I would be very interested.
I wish you would, because these anomalies did not occur above the equator. They didn't start happening until they got further south. Initially, they're minor. But the further south they go, they got greater.
Yep.
And I wish I would have saved it, but somebody actually did the math on it and said that the widening of the lines would account for the anomalies, where they were signing it off to anomalous currents and things of that nature they weren't familiar with in the unfamiliar waters down there. Yeah. But they are in line with what would happen on a flat Earth.
Yeah. All right. Well, I'd love it if maybe not right now, but you could send me that, a different time in on Facebook Messenger.
I'd have to dig it up, and I'd take a shot at it.
That'd be cool. So, all right. I had a guy ask who is an engine builder. Okay. I think he's pretty interested. He's asking if sometime, I think maybe not today, but a different day, he'd like to debate you. He is he's an engine builder, and so kind of a gear monkey, and I think he's intrigued that to have a debate with you, and asking if I would moderate. So, would you be interested in the future? And you could have a chance to prepare a lot better too, with the guy. He goes by Crashes. He builds a lot of RC cars too.
Okay, well, that's no problem. I build airplanes and boats and things like that, and cars. So I had my time there.
There it is. I'm trying to set up a debate with this guy. So maybe sometime in the future. He's fun. I think you'll like him. You'll get along pretty well mostly. So.
Well, I could actually hit it a lot more points there. I just don't have them in front of me.
I get it.
Right now, I'm trying to focus on these particular items, and like I said, I'm not interested in pushing a particular point. If you can prove to me, show me definitive evidence that can, produce a curve or things like that, something real and something that can be verified. Because I know for a fact that I cannot prove that a square is a sphere, and I can't prove a sphere is a square. Therefore, there is no real evidence for if a ball is a ball. The only evidence you're going to be able to bring from that is that it is a ball. You're never going to be able to prove it's a square, and vice versa. So, anybody that can produce, verifiable evidence, proof, something that's real, not necessarily just a mathematical formula, which unfortunately can be twisted and at times is subjective. Something like that, something I can put my hand on and verify. Hey, I've told people 1,000 times, I got no problem. If you can prove it, I'm good with it. But from my perspective, the preponderance of proof is all on flat Earth. Now, I appreciate what you're showing me here, but there is a lot more to this. This is, we haven't even covered the tip of the iceberg yet. Like I said, you wanted to talk, I'm perfectly happy to talk. I'm not going to shy away from this stuff.
Yep.
Like I said, I've been checking it out for 7 years. Now, see, from your perspective, I see exactly what you're doing. You're very dedicated to the sphere idea, and that is where 100% of all data is geared towards. You have to hunt and find the anomalies, to really raise the question marks. How do you deal with a gyroscope on an aircraft?
I think it's great evidence for the globe. So I don't know what you're talking about. But
gyroscope maintains its reference constantly relative to nothing except its original startup point.
Yeah, but in an airplane they have pendulous vanes, and if you've worked on them, then you'd know that.
I have. Yeah, extensively. I've been to school on them.
Yeah. So what do the pendulous vanes do?
The pendulous vanes? Are you talking about Okay.
Did you go to school on them or not? Because
yes, I did.
Pendulous vanes are in
technician.
Mechanical gyroscopes in airplanes.
Okay. Then you tell me what you believe they do.
Well, when
maintain an aircraft straight and level, aircraft references from the gyro, and they have inputs from accelerometers as well. Actually, we use multiple gyroscopes: ASN 15, ASN 24, all this stuff that I've worked with extensively.
Yeah. So, are you talking about mechanical gyroscopes or optical gyroscopes?
Mechanical.
Okay. So a mechanical gyroscope, as you said, keeps its position relative in three-dimensional space, unless it's acted upon by something, and that's what the pendulous vanes are for.
Yeah, to detect the movement.
No, the pendulous vane is swings. When you tip the plane, for example, you don't want it to immediately refigure down for where you're going at, and that can cause accidents, right? So the pendulous vane works slowly over time. So when you go around the curve some, right, it tips that little vane to the side a little bit, opens up a port so that
how would it know how would this vane know you're going over a curve?
So it's always being held relative to the downward acceleration. So as you go farther,
level flight, in straight and level flight there is no downward acceleration.
Exactly. So, but once you've gone over and you've changed your orientation some, the pendulous
vane.
Why
did you change your orientation?
Hold on, let me finish. When you've changed your orientation, say you go 70 miles and you're 1 degree around the curve, right? That pendulous vane will come off just a tiny bit, and open up the port so the air can come through, and it pushes it results in a force.
Air blowing into a gyroscope?
Blowing out of the gyroscope, yeah. So it's inside and...
No, these are hermetically sealed units.
Yeah, but the outside the unit, yes, but inside the unit has the pendulous vanes right up against.
There's no air moving inside these things.
Okay, well, I can bring up a video showing pendulous vanes if you want to see.
I'm sure you can, but that's an application that I'm not familiar with.
All right.
But I know that the ones I was working with are hermetically sealed, and they
okay.
result,
So you
they
don't work
respond
on
to
the
directional
inside of a mechanical gyroscope,
I have.
but you said they're hermetically sealed.
They are.
Okay. So
We
do
have
they?
a sealing.
Are the ones that you've worked on? Do they have pendulous vanes?
Not that I'm familiar with, because they have no airflow inside. These things rotate at about 24,000 RPMs.
Okay. So I'm not certain you've worked on one.
Hey, no, look them up. The ASN 50 gyro, the ASN 24 gyro, standard. I mean, they're probably a little outdated now.
Well, they've had them. They've had them. Pendulous vanes have been in these for longer than just recent. So, let me see if we have something that we can show a little more quickly than just.
So you're suggesting that a gyroscope does not maintain an aircraft in straight and level flight?
Sorry, say that again.
You're suggesting that the gyroscope does not maintain an aircraft in straight and level flight?
Straight and level flight. Level is. It is absolutely level. Level is the curve. That's the curve.
Hey guys,
surface.
real for you here.
No, level is level. Level is not relative to a curve.
Oh, I'm sorry. Let me pull that up first. Then I guess.
Okay, what are we pulling up?
The definition of level. So just a second here.
It would be straight. It's an aviation term. Straight and level flight means.
All right. So here's a book from 1814, The Theory and Practice of Surveying, containing all the instructions requisite for the skillful practice of the art. Leveling. The true level is a curve conforming to the surface of the earth as ABG. So ABG on this graph here is the curve. Right?
So you're suggesting this curve is level?
The definition of level. And we don't get to redefine words that entire industries have been using for centuries. They have meanings, right? So
I know what level is, and I know what straight is.
Yeah, they're not the same thing.
Neither of them.
So here is another one, right there. The level surface is a curve in this one here. You can see here level surface is again over on the right side. Oops.
So you're trying to tell me that which is level is actually curved?
Absolutely. The definition of level is a curved surface. Here's another one. I have
if you were referencing it off the surface of the Earth in a gravitational mode.
Yeah, well, that's the definition. So I mean, we don't get to redefine words.
That's the definition of perpendicular to the axis of gravity.
Absolutely, and you can see here, right in this one here,
the horizontal line is
horizontal is the plane perpendicular to the pull of gravity in one position.
Yes, and your level line assumes a curved Earth.
Absolutely, and so measurements would be key to finding that. So
it assumes a curved Earth.
No, it's measured, but I can show you measurements of that if you want. So anyway, I sent you this in Facebook Messenger as well. It's about 45.
The dictionary says. Wait a minute. The dictionary says level is a noun, a horizontal plane or line with respect to distance.
Yeah, I'm not just looking at that one cherry-picked definition.
A given point. Above or below a given point.
Yeah, so here's Webster's Encyclopedia of Dictionaries. Right here. Level surface, a surface which is everywhere perpendicular to the direction of gravity. Right?
Wait a minute.
The flight level, surface level.
Level is a straight line.
Oh, can you show me that definition in a technical manual?
I can show you that is exactly what I'm. Go on.
Is somebody getting worked up there?
Yeah, girlfriend's listening here. He's getting a little aggravated. She gets aggravated a little more easily than I do. No, what you're doing is trying to apply a definition that you are well aware that I do not intend. You're going.
Sure,
Okay, that's
but
not the point. Yeah,
when
you're
a
going
pilot
you're going
when a pilot says straight and level flight, it's not what you intend, it's what they intend when they say that. Right?
Okay, the point was that a gyroscope maintains its reference to itself from the time of startup. Right? We'll just say a plain gyroscope without pendulum effects and wind blowing into it. All right? It does not change relative to anything, gravity, curvature of the earth, and that is what I'm saying. When a straight and level flight, you are actually flying in a straight line, not a curved line.
But that's a claim, and we can test that.
It's a claim, and you can test that.
Yeah, it's a claim.
When a pilot flies a plane, he maintains his altitude a number of different ways. You can do it by rate of climb, you can do it by your relative altitude, or you can reference it off your instruments. Multiple ways to do it, but true straight flight is straight and level. That is what is called.
So that's a claim. Do you have like measurements of this though, or anything?
Look, we came into this as a general discussion. You're all prepared with your computers and all your back stuff, trying to take me down because I don't agree with you. And you have all your criteria right there, and then you're asking me for specific breakdowns, definitions, exact examples, and I am talking in generalities.
Sorry,
because
my audio kept kicked out. People can hear you, but I can't. Just a second.
Are you there?
All right, I think I can hear you now.
Hear me at all?
Yep, there we go.
Point is, you're telling me you weren't really prepared for this, yet you have all this stuff here ready right at your axis. I'm sitting on a boat in the middle of the freaking water right now talking on my phone, trying to come at me and demanding specifics and suggesting that because I can't provide instantaneous specifics that therefore I'm wrong, doesn't work. That's not legitimate debating.
Yeah, that's
demanding. And when I tell you a plane is in straight and level flight, that is exactly what it means. You want to break down the definition of level and apply it to a curved surface, and I'm supposed to rebut that. Well, I don't have that access to that kind of information right now. That is not appropriate debating, and you're taking advantage of your position to try and make me look stupid. Well, I'm not stupid. All right. Now, don't split hairs with me over things, but you know what I mean when I say straight and level flight. I know what straight and level flight is. I am a pilot. I spent 10 years in naval aviation working on those gyros, inertial navigation systems. I know how the stuff works. All right. Now, you want to come at me and you say, well, I don't have specifics and exact examples. I can find 3 or 4 different definitions of level, depending on where you research. You just did.
Yeah, I got, so it's 45 that I have. So 45. I sent you that list though, so you can look at that at your leisure. So, yeah. Let's see, we're getting close to 2 hours here. I wonder, sometimes
I got to be headed to bed pretty soon.
Yeah, it's getting late for you. You're in Florida, so I wonder if sometimes people have questions in the chat, so maybe we want to look to them a little bit. I got a couple people that said things. Somebody said a little I think a rhyme. Let me see. MCToon, he's our Glober man. He can squash flurfers. No one can. Have a good show.
Well, when you figure out what that means, email me.
That's from Ilya Moon, a friend of mine. Surf.
Doesn't sound like it.
Surf, another friend says, you know that waves don't shrink. I don't know what that means, but yep. And then Lael is fun. Let's see. Captain Cook's journey main purpose was to better triangulate the transit of Venus across the sun to get a better distance to the sun. Yeah, and I am aware of that part of his journey. how he brought he was bringing people to South America, I think, to get they could measure the transit of Venus across the sun to
I'm sure
try
he had a multitude of purposes.
to parallax, right?
Mm-hmm.
Let's see. Oh, Heat Shield says in a couple weeks when I'm you're popular here, Mike. When I'm in a couple weeks when I'm oh, there we go. When I'm at my new place, he's moving. I'd like to talk to this guest about flight. He has to solve direct checkerboard. I have to solve direct checkerboard to keep on mind. I'm not sure what that means, but
I think it has to do with something. I've seen it something to do with ley lines on the Earth. You know, three-sided dimension. I don't know. I it's in my head what he's talking about. I believe, maybe not. I don't know.
somebody says ask Hulk Hogan. I guess that's you. If he has pendulous veins. Well, oh, Poe, naughty Poe. I'm not going to read that. So, all right. Well, anybody else have any appropriate questions? I can solve my Rubik's Cube. You can see it's like see-through because of the color and my green screen. Now you see a moon behind me. Everybody else sees a thing from the movie Tron. So
Look, there's a good one. How much time you got left?
what's that?
Your moon.
What about the moon?
How is it that a celestial body like the moon is able to maintain one face absolutely relative to the Earth over time?
Yeah, that's a complicated one, and I don't fully understand that, but people do. Oh, that's not.
Well, I'm sure they have explanations.
Yeah, it's called tidal locking, and it's predicted to happen.
Tidal locking.
Tidal, yeah.
Is it implying does that somehow imply that the moon also affects tides?
Absolutely, yeah. The moon does affect tides.
Causes tides? It causes tides?
Well, the Earth and Moon together orbit around the barycenter of which is the average position of the mass between them. So it's actually the barycenter of the Earth-Moon system is within the Earth, and so the Earth doesn't.
How do we get the same tides on nights when there is no moon?
Yeah. So what happens is
how do I get multiple tides in different locations 20 miles apart?
If you see this, right? So here, imagine this is the Earth, right? And the moon's going around it. And so what happens is the Earth does very small little circles like this because the barycenter of the Earth-Moon system isn't right in the middle. It's to the side a little bit. And so the Earth-Moon system does that a little bit like that. So the tides are caused not primarily by the moon pulling on it, but they're primarily because the Earth is actually doing these small little cycles. And
you get change in weights and measures.
You do get a measurable change in weight when between a full moon and a new moon versus a quarter moon, and where the sun is in alignment.
Interesting point.
These have been measured. A guy in chat actually has
a guy.
Yeah,
in chat.
A friend of mine is
talk about my vague references.
Hold on, I didn't finish my sentence even. Friend of mine has is working on getting a demo going where he can actually get some things together that are able to measure the downward acceleration to up to 9 digits of precision. So
that should be useful.
All right, I was here. So yeah, so the Earth-Moon system, they rotate around the barycenter.
Barycenter.
And that's what, that's the
Chicago.
No, the barycenter is the center of mass between the Earth-Moon system. So it's slightly off center of the Earth's
Well,
center.
I got okay. Since we're running a little low on time, I want to hit on a few little things. Whatever pops into my mind is things like let's say the axis of the Earth, 23.4 degrees, right?
About, yeah.
Okay. Why do they measure the angle of the Earth from vertical being 90 degrees rather than horizontal being 0 degrees?
So it's, hold on. I got a globe here. Hold on. Because when you have something rotating, right, you've got your axis that goes through it. So this is,
Correct.
that's 0 right there.
No, actually, that is 90.
Well, it's
Horizontal
arbitrary,
0.
but when in
Arbitrary.
yeah, I mean you could pick this to be 0, right? But typically,
No, it's not. It's no.
Not mathematically.
No. That's not 0. 0 is horizontal in most any setup.
That's arbitrary. When something spins on its axis, the axis is 0.
Okay, well, just for giggles, let's say 0 was horizontal and 90 was straight up.
Okay.
All right. And you say the axis is 23.4 degrees off of 90.
About.
Now, do you not find it an intriguing coincidence that 90 minus 23.4 is 66.6?
No, what's 100 minus 23.4?
I don't
What's
know.
200 minus? It's just an arbitrary number that you picked out of the air.
No, 90 degrees. No, it's 23.4 degrees off of 90 degrees. 0 being the relative 0
Okay.
of the horizontal plane. 90 degrees is straight up. I'm just saying, engineers measure from 0.
Yeah, and 0 is the axis.
No, well, 0 can't be the axis. The axis is said to be 23.4 degrees off of vertical, which is 90 degrees.
There's no orientation in
Here's the thing.
space.
Yes, there is. When they're talking about the plane of the planet's orbit around the sun, that is considered the reference plane, the 0
Yes,
plane.
and so
the Earth's tilt is
23.4. Yeah.
degrees off of perpendicular to that plane. Perpendicular to that plane is 90 degrees.
Okay.
90 degrees minus 23.4 is 66.6, and that's an arbitrary number that was. It's just an interesting point.
And then on flat Earth, how many degrees is it from the North Pole to the Tropic of Capricorn? Or sorry, the Tropic of Cancer. How many degrees of latitude from the North Pole to the Tropic of Cancer?
How is that relative to the angle
on flat
of
Earth? Oh, just making up, picking stuff out of the air from on a flat Earth.
I'm not.
How many degrees?
I'm not picking something out.
Well, I mean, neither am I. So on flat Earth,
I have a very salient point here.
Yeah, but I have the same point. On flat Earth, how many degrees from the North Pole to the Tropic of Cancer?
I could not tell you off the top of my head.
66.6 degrees on flat Earth.
Oh yes, that's it. You think that's just pure accident?
Yeah, I think whoever invented flat Earth did that to because he loves Satan.
Well, flat Earth has been around since the dawn of time. Ball Earth was only come up with. I mean, they were still teaching flat Earth in schools in the 1920s.
Yeah, so yeah, we figured out the Earth is flat about 2,500 years, or not flat, about 2,500 years ago.
Are you going into Eratosthenes or whatever? Eratosthenes and his stick experiments?
No, Eratosthenes measured the circumference. That was all. He already knew it was a sphere at that point.
It's a ridiculous proposition.
Yeah.
That he put two sticks 500 miles apart or something and measure them at the exact same time.
How's that ridiculous?
I don't believe they had clocks back then.
Oh, you don't need a clock. What you do is you wait until local solar noon, which is when the shadow gets its shortest. So you don't need a clock.
500 miles away.
Only where you're at.
How long would it take to travel 500 miles in 2,000 years ago?
You don't need to. What you do is you give instructions to somebody. You say, look,
and then you send them on 500 miles.
At local solar noon on this day, when the shadow is at the shortest, take a measurement.
And the same experiments can be shown to show flatness. It's been done.
And actually, I did that with a friend on December 20th.
Well, you might have had a digital watch and a cell phone.
I did not use my watch. I used the length of the shadow.
I didn't know what time it was.
I used the length of the shadow. It doesn't matter what time it is. It matters the shortest shadow length. Because when you get the shortest shadow length, that's local solar noon. That's all you need.
Okay. Well, rather than get too much further into this, it is actually getting late here. Okay. I'm going to have to call it. We can do this another time.
All right. Well, I will tell you what. I'll get you in touch with Crashes and maybe Heat Shield because both of them are interested. But I thank you very much, Michael.
I can't hardly wait to interact with guys like that.
Well, all right. Well,
they got to be cool.
Thank you very much for coming. You're a good sport, and tell your girlfriend thanks too. And I sent you a couple things there in chat in the chat there. So yeah. Anyway, that's it, I guess. And you can. I'll say a little bit to the people watching along at home when you're done. But. All right. Thanks a lot, Mike.
Hey, no problem. We're going to call it a night here.
All right.
All right.
Bye.
Good night, Mike.
All right, people. Well, hey, he's a nice guy. Good. It was a good chat here. So he's still in the chat. So I'll be sure that he has the link to this so that he can pull it up. I see Green Bullion was talking a little bit. I was not. I know you sent me a few messages. Green Bullion. So I had a discussion with him, and he really wants to come on. So maybe he can. I said you need to be on screen, and he's like, I'm too attractive. I'm like, I don't know. Green Bullion. I think probably the problem is that you're hideously disfigured. So, but. That's the thing. You got to be on screen, bud. So, and I didn't know what exactly you were saying, and people blocked you, and you didn't want to be blocked, and so I don't know. I don't really care. So I'm gonna do another stream, and maybe you can come in here, Green Bullion, afterwards, in just a couple minutes, and on camera, of course. So let's see. I got NANA for $6.66. Hail Santa says, I doubt this guy is legit. By the way, Super Chat censorship can eat a D. Yeah, Super Chat, blocks certain words. You can say words and then they're held, but for Super Chat, they won't let you. So, POE for $6.66. Hail Santa says, analytical microbalance, gravimeters, pull force meter for the win. So, yes, he correctly identified that the moon would have to change your local gravitational pull a little bit. So, absolutely. Quantum Degreaser. He's not just attractive, he's flirtractive. That's how we roll on glorious flat Earth. Well, Quantum Degreaser. I love that name. Good to know. So, what I'm going to do is I'm going to end this one, and I'm going to do the after show, which is, let me pull it up here, which is that's a good video on pendulous veins. I gotta save. I'll put in the link to the new one here in a second here. I'm gonna do a little video review, some memes, and if people want to come in, send me a message on Discord preferably. Though Twitter maybe. I don't check Twitter as often. What am I doing here? And Green Bullion, you're invited, but on camera only. You know how it is. There it is. There's the live stream. Gonna grab the URL to it. Let's see. Sean Hawkins, you asked for questions, and I'm sorry, Sean. I didn't see your question. He wasn't quite interested in answering, so I think he got a little. His girlfriend was getting a little tweaked. So apparently she's a flat earther too. So, all right, there is the link to the after show. I'm just gonna go to the bathroom, say hi to the wife and kids, and I'll be back on in a little bit. If you ask for questions, you should probably not solve your Rubik's Cube. I had to do it once, man. I had to do it once. So, yeah, I'm sorry, Sean. So, all right. Anyway, thanks a lot for everybody for coming. Thanks for watching. And thank you especially to my members and patrons and everybody doing super chats. And we'll catch you in a little bit. Bye.